All right, I'm starting a new series. We're going to keep this short as possible, under 10 for sure, maybe under 5. We're calling these M98s, and they're going to focus solely on little snippets of useful information if you decide to write your own macros for FANUC-based controllers. All right, let's hit the bump. So, this section, as you saw in the title, is just going to be about scoping. Scoping on FANUC controllers is a little weird, and I wanted to do some testing to verify it. So, let's jump into the code. Again, we'll try to keep this super quick. This is a simple little program that I have thrown together to test scope. So, for those who might not be aware, how macros work on FANUC-based controllers is a little funny. There is a variable range from 1 to 33 that lives for the life of the program. Then you have a variable range from 101 or 100 to either 49 or either 149 or 199, and that range will last for the lifetime of the controller being on, so as long as the computer is on. And then you have a range from 500 to 999, and that is available. That's static memory. You save something there, it lasts forever, unless you go change it for whatever reason. Now, there are implications to all of these layers, but the first thing you have to understand is what they actually mean by that 1 to 33 being user level or lasting for the run of a program, because when you start getting into macros, we start touching into concepts like encapsulation, this can really quickly bite you if you don't understand what's happening with these variables. So let's go through this example. What we have here is a very simple, very simple program. All we're doing is calling another macro. We're calling macro number 10. And then we're going to save whatever macro number 10 does. It doesn't really matter what happens. We'll go ahead and save variable 1 to 800. Now, why are we saving a variable to another variable? Most controllers don't have a way to output a variable. If you have a controller that's FANUC based that can output a controller to a log, make a comment below. My controller can't. So just keep that in mind. So very simple program. All we're doing is calling another program, a macro specifically. So let's jump over to that macro. So this macro also very simple. We're going ahead and initializing that one variable. So this brings up the first question of scope. Is this one variable the same as this one variable? And we're going to get to that when we kind of go over the results. Then we're going to go ahead and save whatever we got to 801 again, so we can see the results. So when 110, and this is mislabeled, it is really 110. When 110 is called, my controller doesn't actually care what number you put up here, it just cares the file name. Anyways, when 110 is called, it's going to initialize variable 1 to 1. Then it's going to go ahead and store that so I can look at it later. Then it's going to call program 11. Now program 11 gets a little funny, so let's jump into program 11 and then we'll see what's going on. So program 11, what it's going to do is going to do this little bit of math here. So what this does is this is going to save whatever variable number 1 equals. Now we haven't initialized it in program 1, but we're going to save whatever that variable means to us in our program. We're going to save that to 801 plus whatever number 1 equals. So if number 1 equals 0 or null, it'll just save it to 801. It'll overwrite whatever we wrote here. However, if it has a value, it will stick it in another, it will stick it instead of 801, it will stick it in 802. So we're going to go ahead and add 1 to 1. So now in theory, 1 could equal, it's either going to equal 1 at this point, or it's going to equal 2 at this point because we have set it. And this is where we get really funky. We're now going to do loops where we call ourselves. Now in programming, this is called regressive code, where a code calls itself. You're basically building up a spring. We're not going to go into regressive code right now. That may be a topic that's interesting to cover later, like how would you use regressive code for building macros to do things for you. Maybe surfacing logic might be a really great example of regressive code. It is a form of encapsulation, but what we want to do here is we want to create layers depth, because we want to see what is the scope of this variable, what happens to it, because the definition of it lives for the running of your code block is very great. Is it running of the whole program? Is it running of just your macro? What happens if you pass variables around? Could you accidentally make mistakes? We need to know what they mean by that. And this programming language is very old, and so some of these concepts that I'm touching on may not have been like fundamentally like a thing when this language was written. It's very clearly a very old language written for very small, very weak processors, which we don't have today, but at the time. So now 1 is either going to equal 1 or it's going to equal 2, potentially. We don't know. So what we're going to do is a while loop while 1 is less than 5, and we're going to call ourselves. So basically we're going to come right back into this loop. So if when we say the range for code, the range for a variable is the code block, and the definition of the code block is a single file, a macro or whatever, then we actually expect this variable to never end, because we will constantly get, we'll get an error. In my case, I could go 27 loops deep, total loops deep, including system loops, total 27 loops deep before my machine cratered. And it would throw an error because it couldn't initialize loops deeper than that. So in theory, we would basically get what we would call a recursive error, because this is a recursive function. We basically just keep calling ourselves. We would never get an exit condition, so we keep digging deeper and deeper and deeper and deeper in trouble. So this is a great way to test scope and what we mean by scope. So before I go on to the results, I want everybody to pause the video. And it's okay, I'll wait. And go ahead and jot down on a piece of paper, what do you think will happen? What do you think variable 800 will be? What do you think 801 will be? And what variables will this impact? And what will the numbers be here? Think through it. Again, I'll show you these one more time. 800, what's the 800 going to be? What's 801 going to be? And then what's going to happen here? What other variables are going to get written here? All right, I'm pausing. Oh, you're back. Sweet. If you didn't pause and you saw me be silly. If you did pause, then awesome. Let's go over the results, and let's go over what they mean. So here's what actually gets stored. 800 gets set to 5. Now 5 is an interesting number, and we'll talk about why that is. 801 gets set to 1. That we kind of could figure that out. 802, so this did 800 plus 1. 801 plus 1 is 802, so we stored the variable 1 into 801, which means, this is very important, this variable persisted at least between this and this. So we have confirmed that the variables can coexist between parent and caller. But what about the parent's caller? What about the grandparent? Can it go there? So let's find out. Let's look at that. Let's go through the rest of this, right? So 803 was 2. So 803 is actually a call into here because it's recursive. So we made a 98. We came back through. The variable was 2, so we stored to 803, 801 plus 2, and we stored a 2 there. Same thing for 3. Now we're deeper in the spring. We don't actually exit anything inside of that second loop. We're going to go back into the loop again. We're going to store that value. We're going to do the same thing for the 4th time through the loop. We're going to go through the loop. And then United, notice there's no 5. Why is there no 5? So if we go through the loop here, we're going to call this on 4. We're going to go to depth 5. We're going to store the 4 at the 5th depth down. Right? We store the 4, but then 1 equals 5. And here we say less than. So then 5 is going to fail out. So now we're going to exit the 5th loop of the spring. And we're going to come back through the 4th loop. So exit the whole program. We're going to come back to the 4th loop. And the 4th loop, this condition is going to fail. And so we're going to end the 4th loop and go back to the 3rd loop. And we're going to do this all the way back up. And so this is what actually happens. The main program runs. Okay, and then to finish it off, that 5 is actually the value here. So the grandparent knows the value of the children. Now, this can get really tricky then. That means that you only have 33 variables for all the macros you're going to run as scratch space. And then if macro A calls macro B, and macro A uses, let's say, 22, and macro B uses 22 for something else, macro B could stomp on and break macro A. That can be very dangerous and very bad. So that means we're going to have to come up with some strategies later on, not in this video, to deal with what we call encapsulation. How do I write code that I can reuse it so that it is what we call dry, which means don't repeat yourself. So if I'm going to write a chunk of code, I want to write that code in a way that I can use it all over the place in my programs and be reusable. A good example of that is the touch probe algorithms I'm writing. I'm going to have lots of reusable code in that. I don't want to write that more than once. So how do we be dry? Because what's happening is the main app runs, it calls 101. 101 initializes this variable, 10. 11 is called by 10. It adds some value to it. It calls itself, which calls itself, which calls itself. Eventually down here, the loop criteria fails. 1 no longer is less than 5. And so that loop exits, and then the next loop exits, and the next loop exits, and then the next loop exits. And all of these macros are ending, and then finally 10 ends, and then finally our main program ends. So hopefully that gives you an idea. Well, one, the recursive stuff isn't important. What it was, it's there to help you kind of get an idea of scope. So the simplest way to put it is we have, when we talk about local scope, they'll use the term local scope or user scope or terms, but local scope, if I can type, which is 1 to 33, this scope can be stomped on by anybody in this range, which means you have to be very sensitive to the scope coming in, you calling something else, and that something else has the risk, unless you're careful, of damaging what you have. And 1 to 33 includes all your passings. If I pass Z, makes sense, I might do a G65, some macro, and I'm going to pass Z in. Great for probing, right? I'm going to probe my Z height. Well, if I pass in a Z, that comes across as variable 26. And if I then call some other thing inside my macro, and I decide, I'm going to write a loop, and I'm going to use 26 for my loop because I need some scratch space for a loop, I'm going to break what Z means to the parent, to the caller, as the term is usually calling and caller. So the called function could break the meaning of variable 26, which is Z, from the caller function. So the caller function could, okay, I need to do some math on Z, and then I'm going to call a macro. When the macro's done, I'm going to do some other math on Z. Well, depending on what that macro does, I could totally break the meaning of Z. So very careful. We have to think about this. So understanding the scope is going to help you a lot. Hopefully going to decrease the amount of bugs and other issues you have with your macros as you decide to develop them. Anyways, I hope you thought this was a little bit interesting. Subscribe, like, dislike, whatever. I just wanted to throw that out there real quick because I ran into this and I thought this needs to be shared. So as I run into more macro stuff, I want to talk about the concepts of garbage collection. I think is going to be really important here, especially understanding variable scopes. Concept of encapsulation, we talked about that, and then just some other ways to how do we approach development when the only way to debug is like on a machine, and that's a really slow, painful way to debug when you're used to modern software development. So thanks for watching, and talk to you guys later.